Okay. So we're looking at quadratic form data. I think y'all have seen this before, probably. I think you'll, if you have, I'm pretty sure you've seen this before. If not, then we'll see. All right, so this is still tying back into quadratics, the graphing we were doing, the factoring, the solving, all the stuff we were doing. So in this case, if they ask you to do one of these, so here's basically what it comes down to. You've got this ax squared plus bx plus c equal to 0. You try to factor it, it won't factor. You don't want to spend the time graphing to go back and then do this thing, because even then you may not get the solution. So quadratic formula, this is your fail-safe. If you ever have to solve something and you don't know how to get the answer, you can always go with this one. Now, I'm going to do this one a little bit different than what you've probably seen it. You remember this, the negative b plus or minus b squared minus 4 ac divided by 2a. Everybody remember doing that? Yeah. All right, now, one thing I've noticed, and this is something that doing one little simple thing has kind of helped out in the past, is that anytime you plug in the a, b, and c values, put it in parentheses. And if you will do, and actually the way we'll do it, it's almost like a two-part thing today. If you do this, it will make the work a lot easier when it comes off of it. Because sometimes people plug in the numbers, and a lot of times it's the very first number that they'll forget to do the minus b, that they'll forget to change that one. So I think if you put the a, b, and c in parentheses when you plug them in, that should really help when it comes off of it. So does everybody does remember seeing that at some point in time? I heard a no in there somewhere. So yeah, it may have been a while. It may have been a couple of years, but talked about. You may have heard discriminant. Yeah, the discriminant is the inside of the square root. And based on what the discriminant is, it tells you how many answers you have and what type of answers you're going to have when it comes off of it. So we're looking at just the inside of the square root part that's here. So where we've got, this b squared minus 4ac, that's what we're looking at right there. Okay. Now, so here's kind of your things. Here's what we're looking at. If the discriminant is greater than 0, you have 2 real, I'm running out of room here, solutions. So if your discriminant's greater than 0, you're going to have 2 real solutions. That's if we got, like we had up here a minute ago, if we had square root of 150. You can break it down and make it plus or minus whatever it is when we break it down that part. All right, what if the discriminant is equal to 0? Yeah, you take the square root of 0, what's the square root of 0? It's 0. What happens? So what happens? There is no plus or minus 0, right? Because if it's plus or minus 0, it doesn't matter. It's still just 0, so you don't have to worry about the plus or minus. So in that case, you only have one solution. Well, actually, so if we look at your square root here, if you take this part, because it's going to be negative b plus or minus the square root of b squared minus 4ac. If this thing is just 0, then that part goes away, right? Okay. And then, look at that. Look at that, negative b over 2a. Where did that come from? Vertex, right? Yeah, you did the last test we did when we found the vertex and we did the negative b over 2a. Oh my gosh, you mean all this stuff goes together? So yeah, if you take out that, there you go. There's your vertex. There's your negative b over 2a. Yeah. And now people now the minds are blown, right? It's like you think this stuff goes together? Yeah, it all goes together. It's amazing how all this stuff just kind of fits together for this thing. And again, there's our one solution because if you take out the discriminant, you've got negative b over 2a, and now we're back to the vertex thing of it, and then we kind of start tying it with it from there. So. Okay, and then one other option. What happens if your discriminant? What happens if your square root is less than 0? How many real solutions do you have? Yeah, if it's a negative number, you don't have any real solutions, right? You have no. Now here's the catch on it. Real solutions. That's the key word there. There's no real solutions if the discriminant's less than 0. But you have 2 imaginary or complex solutions. Okay. And that's one of those where sometimes that's where you have to kind of watch and see what they ask for. Because if they ask you just for 2 solutions, and that square root is negative, you could give me the imaginary solutions and it'd be okay. If they say, how many real solutions do you have? Then you'd say, all right, I don't have any. There'd be none for that one. So that's one of those you have to kind of watch the words on a little bit, because depending on how they word it, if they ask how many real solutions can you have, it's either 2, 1, or none. And again, if imaginary is in there, you don't count imaginary because it's imaginary. It's not real, so you have to kind of kick those out. So it's all on the wording. It's how many solutions you have that are real or not, depending on how they want to ask this thing. All right, so what we're going to do is we're going to kind of do 2 steps in one for this one. We're going to talk about what the discriminant is first, and then once we've got the discriminant, we're going to use that to then find out how many solutions we got and what they are, and kind of go from that part of it. So. All right, so we're going to use the discriminant to determine the number of real solutions and then after we figure out how many solutions we're looking for, then we're going to find those solutions. And we'll put the old famous apostrophe or parentheses S because it could be solution, it could be solutions. And then what we're going to do on this part is that we're also going to do this, that if the solutions are imaginary, or complex solutions, they could say it either way. We're going to name them also. Okay, so very first thing is we're going to find out what the discriminant is to find out how many real solutions we have so we know what we're looking for. And then once we do that, we're going to find all the solutions, whether they're real or imaginary. We don't care. We're going to go back in and find them. Now, sometimes in the homework, it may not ask you if it's imaginary. They may tell you to stop. But just for our practice, we're going to go ahead and find them anyway, just because it's good practice. Because one of the next things that we'll do, we'll talk about the imaginary solutions. So we're going to go ahead and do that anyway because it's just good practice. All right, so for example 1, we're going to go kind of easy one on this one. We'll kind of build up to the tough ones as we get there. So we're going to go x squared plus 5x plus 6 equals 0. All right, and again, get the easy things first. Your a value is 1. Your B value is 5, and your C value is 6. All right, so when you go discriminant on this case, you've got B squared minus 4AC. When you plug in these numbers, put the numbers A, B, and C in parentheses, because if you do that, it should take care of like 90% of any questions you have on this. All right, so our B is 5 squared minus 4 times A times C. All right, now I would say do two things on this one. I'd say number one, go ahead and see what your answer is by hand, see if you can do it. So that's 25. 24. Yeah. So it's 25 minus 24, so that one should be 1. And here's what I would say to do. When you do these, I would then turn right back around with your handy dandy calculator and just double check it, because if you can get this part correct, you've done the hardest part to any problem that you've got to do for this thing. And I would take it just like you've got here with what you've got here, plug this thing in and make sure it's good, because this is where it's good to be able to use calculators. Because again, y'all are about what are we about a month and a half away from the juniors taking the ACT. The one that you have to take, I think it's April 15th. Is that right? Yeah. Yeah. I was thinking April 11th, April 15th. Yeah, somewhere in there. So we're about a month and a half away from everybody taking the ACT for the juniors. So, okay. So that one, you definitely want to practice your calculators a little bit. So that's 5 squared minus 4 times 1 times 6. And I'd punch it in just like you got it there. Again, it's good practice just so that you can kind of see if you're getting the same numbers here. And if you are, then there we go. All right, so we got that one. So we've got B squared minus 4AC is 1. So based on that number, how many solutions are we going to have? Yeah, because 1 is greater than 0, correct? So that means we're going to have 2 real solutions. All right, so now we know we're looking for 2 real solutions. They may have radical numbers, but they may not. So we just don't know until we go back and start plugging this thing in. All right, and if you've got this, here's where the good part is that the hard work is done now, because now the easy thing is we're just going to plug into negative B plus or minus the square root of B squared minus 4AC all over 2A. Well, you've done the hard work, because that's the 1 that goes in right here. So that's just the square root of 1. All you got to do is do the negative of B plus or minus that over 2 times 1. So that's the negative of 5, which is just negative 5, plus or minus, well, square root of 1 is 1. 2 divided by 1 is 2. So that's just negative 5 plus or minus 1 divided by 2. And there's where we just split up and do it the 2 ways. You do negative 5 plus 1 divided by 2. And we're going to do negative 5 minus 1 divided by 2. Okay, so that's negative 4 over 2, which is 2. Negative. And then negative 5 minus 1 is negative 6 over 2, which is negative 3. All right, and there's your 2 solutions. Okay, and probably Math Excel will give you that box where you got the x equals, and then we'll do a negative 2 and then a negative 3. Okay, now picked an easy one to start with, where we had a perfect square root that it made working through the numbers, fairly easy. Next one we go through, we're not going to have a perfect square root, so that it's going to be, you got to work on it, got to break it down a little bit. But everybody feel all right with that one? And again, if you do the discriminant, you've done the hard part of the problem. Everything else is just doing a little bit of simplifying because it all should be pretty easy after you get past that. All right, so let's go with x squared minus 6x equals, not a negative 10. Sorry, it's just a 10. All right, so for this one, the very first thing you've got to do is before you do anything, you got to move that 10 over to the left side. So you make it x squared minus 6x minus 10 equals 0. You've got, if you're going to use quadratic formula, just like when we were factoring, you've got to pull everything to one side. Okay. Now, even if they tell you to, and this is something we didn't do back here, could you factor this thing? Are there any factors of 6 that equal 5? 2 and 3, right? So we could have just factored this thing back here and had, x plus 2 and x plus 3 and set that equal to 0, and then we'd have gotten the negative 2 and negative 3, right? So even if they tell you to use a quadratic formula, if you look at something you go, well, I can factor this thing, go ahead and factor because factoring is going to be a lot easier than doing this. I just want to give us one to practice on, an easy one to kind of go through. So if you get a problem and you're like, well, I can factor that, then factor it. Don't use the quadratic formula because it's going to be 3, 4, 5 times as long to do it as it is, the non-factoring way. All right, so for number 2, for this problem, it will not factor because there are no factors of negative 10 that's going to get you to negative 6. Because it's either 1 and 10, so that's either 9 or 11, or it's 2 and 5, which either gets you 7 or 3. So there's no way you can take those numbers and get 6. All right, so for this one, our A is 1, our B is negative 6, and our C is negative 10. Okay, and again, for the discriminant, it's B squared minus 4AC. And just to kind of practice on this one a little bit, again, we're going to plug in the A, B, and C, but put them in parentheses. So it's negative 6 squared minus 4 times A, which is 1, and C is negative 10. Okay, so here's where it comes down to either how good your order of operations are or how good your calculator skills are. If it's negative 6 squared, that should be 36. If you've got negative 4 times 1, that's negative 4 times negative 10. That should be a positive 40. So I'm getting that should be a 76. All right, and if you're not real confident in your order of operation skills, your calculators should be, so we're going to do the same thing just to double check it. We got negative 6 squared minus 4 times 1, not that we need the 1, times negative 10. And we do get 76. Okay. Now somebody's going to ask me on the test, are you going to have to show your work? Probably not. I'm just going to look to know if you know the discriminant. So, on the test, if you want to be able to use your calculator, I'm fine with that because as long as you can find it, I don't care if you find it by hand or find it by calculator. The main thing is just to find it. So in that case, we've got 76. So how many solutions are we going to have?
3.
All right. So we got 2 real solutions. Because 76, how does it compare to 0? Well, it's greater than 0. So we got 2 real solutions. All right, now we got to go find out what those 2 real solutions are. So again, we're going to go negative. We're going to plug in the B value, which was negative 6, plus or minus the square root of. And again, we've already done the discriminant here, so we know this number is going to be 76. And that's over 2 times 1. All right, and when it comes out to 76, it's not a perfect square root, so we got to break it down, right? So for 76, if we break it down, I'm going to go factor tree. That's 76 divided by 2 is 38. 38 is even number. We can divide it by 2 to get 19. 19 is prime. Can't do anything with the 19. So that's 2 times 2 times 19. There's a pair of 2's. So we can take that 2 out and make that 2 square root of 19. Okay. And then, so there's that part kind of, we've simplified the square. And some people are like, well, can we go ahead and simplify the square root before we plug it in the formula? If you want to do that, that's fine. Because you're going to have to simplify this thing anyway. So if you want to go ahead and break it down and then put it in, I'm good with that. You've got minus negatives to make that a positive 6. Plus or minus 2 times 1 is 2. Okay. And then here's where, again, you've got to kind of look at it, because if you notice the whole numbers, that's 6 divided by 2, right? We can simplify that one. If that was 2 square root of 19 divided by 2, we can simplify that one, right? So if you've got parts of these that you can simplify, go ahead and simplify. So if you think about it this way, we're going to take 6 divided by 2 and break it up. And we got plus or minus 2 square root of 19 divided by 2. So if you've got this one big fraction over this, go ahead and separate it into parts, because now you've got 6 divided by 2, which is 3. These 2's will cancel, and that's plus or minus the square root of 19. And hopefully with Math Excel, they'll let you leave it just like that. If they don't let you leave it like that, you're going to have to do 3 plus the square root of 19 and then 3 minus the square root of 19. And it's kind of 50-50. Sometimes they're okay leaving the plus or minus in there. Sometimes they're not. I'm good leaving it like that if you want to leave it like that. So, Charleston, question?
So if it had been 6 plus or minus.
All right, 1 or 2 more, and then we'll wrap this thing up here. All right, so let's go with 3x squared minus x plus 5 equals 0. Okay. Now, if this were me, the very first thing I would do, even if it told me to do the quadratic formula, the very first thing I'm going to do is I'm not going to do that. I'm going to check and see, all right, what if I do 3 times 5 and I get 15? Are there any factors of 15 where the sum is going to equal negative 1? 1 and 15 is not going to work. 3 and 5 is not going to work, right? So none of that's going to work. So factoring is not going to work. So factoring is out. If that was a 2 here, maybe. But even with that was a 2, the sign I think was going to be wrong in that case. So for that one, factoring is not going to work. All right, so we're going to have to go with quadratic formula. So A is 3, B is negative 1, and our C value is 5. Okay, so let's go and see what we got. We got B squared minus 4 times A times C. That is 1. And if we do negative 4 times 3, that's negative 12 times 5 is negative 60. 1 minus 60 is negative 59. So how many real solutions are we going to have? None. Okay, now in some cases, if they say if there are no real solutions, just put none and you're done. Now, and that's if that was the case, we'd stop and say there's no real solutions. We're done. Now we're going to go ahead and do it because we know how to simplify negative square roots. We're going to go ahead and do it and see what that answer is going to be. So, all right. So for solution wise, we're going to have negative b plus or minus the square root of negative 59, and that's over 2 times a, which was 3. Okay. Now, if you start to break down 59, does 59 break down? Odd number, right? If you divide it by 3, that doesn't work. Definitely can't divide it by 5. If you try dividing it by 7, 7 doesn't work. You know, if 3 doesn't work, 9 is not going to work. You go through the numbers, it doesn't work. So that case, 59 is just prime. So it will not break down. So it's done. There's not really anything you can do with that one. You do have minus negative, so you make that a positive 1. On the bottom, we've got 2 times 3 for 6. And in that case, the only thing you can really do for that one with the negative 59 is to take out the negative. And again, they'll either let you put it one of two places. They'll either put the I here, or they'll let you put the I there. And if they do this correct, and this is where I don't like Math Excel because they're not real consistent on everything. If they were going to do this like they've done every other problem, they should break it up and have it so that it's like this. Because you technically should take each part of it and see if you can simplify it. Now, in that case, neither part's simplified, so I kind of understand leaving it as one fraction. But, so any one of these 3 to me is okay. If they count it wrong in Math Excel, just look at it and look at the view example to see how they got it written, because sometimes if you've got it written this way, they don't like it. And if you write it this way and they still don't like it, then they probably want it this way. And sometimes they make it so that you have to put the I in a certain spot. But I'm okay with any one of those 3 answers if we're doing this thing by hand. So. Okay. All right, so let's do one more of these. And this we're not going to factor this part of it. We're just going to find the number solution. So we're not going to break this one down. We just want to find out how many solutions we have. So we're just going to state the number of solutions. We're not going to find them, and that's all we're going to do. Okay. Again, first thing hopefully you did was you add the 2 to both sides. A is 2. B is negative 4. C was 2. So if we plug that in, that's B squared. And again, be careful with that one, because if you've got the negative, make sure it's in the parentheses. B squared minus 4 times A times C. So it's 16 minus 16. Everybody get 0? Question. How many solutions?
1.
Yeah. Okay. We got 1 real solution. Okay, now I didn't ask you in this case, but we're going to go ahead and just kind of so you can see what's there. That if you're going to find out what that, here's where the easy part of that one is. If it's 0, then your real solution then is going to be negative B over 2A. And again, that's the whole vertex thing we had going a little bit ago. So that's going to be the minus. Again, be careful with your signs, because if it's negative B over 2A, you got to think about it that way. So it's minus negative 4 over 2 times 2. So that's 4 over 4. So that means we'd have one solution at x equals 1. Okay. So if you do get 0 for your discriminant, then your solution is also your x coordinate of your vertex at the negative B over 2A, which is would be at x equals 1.